Welcome, class, to your first video for Algebra 2. I'm Mr. Mitchell, and we will be learning Algebra 2 together. Well, you will, and I'll learn some stuff along the way. Anyway, this is our first video. It follows along with the textbook. I'm going to go over some best practices, things that I think will help you do really well using the videos and doing practice on your own. First off, you should have your textbook. It's way easier if you have a hard copy textbook instead of scrolling between screens and accessing the online textbook. You should also have a notebook. I'm not taking notes for myself. You're going to hear me say this a lot this school year, and then if you have me later on, but I've already done it. I've been doing it for many years, so I'm not doing this for myself. I'm doing it for you. I'm trying to break it down so that you can start to access the information. You're probably not going to understand it right away, so don't expect to, but you're going to start, and you're going to put in effort, and you're going to struggle at times or breeze through some things as well. But it starts with a notebook, okay? This is a video because we all learn at our own pace, or sometimes we're absent from class. So you can pause it if I'm going too fast. You can rewind it if you need to hear something again. This is really for you to go through. I don't suggest going through it too fast because you've probably not seen a lot of this stuff before. I try to go at a pace where you could probably write most things down as I'm doing it, but not everything. So I do expect you to pause. I do expect you to rewind, okay? All right, so take a deep breath in. Let it out. Let's open our textbook to page 4. We're on chapter 1, section 1. We're talking about parent functions and transformations. So on page 4, there is a core concept. It's important that you write this core concept down because this core concept is showing you what a constant function looks like, what a linear function looks like. Okay, those are two things that you probably have seen before. Okay, here's something you might not have seen before. An absolute value function. Okay, what does it look like? What would you describe to a younger sibling or a relative? And then finally, you might have also seen a quadratic function before. And what does it look like if you were to give it a letter? Okay, what would you say to someone younger who's never seen it before? All right, so those are your parent functions. You probably by now should have paused, copy down the core concept on page 4. All right, and then I'm going to help you answer the questions in the way that the textbook is presenting it to us. So at the bottom of page 4, let's go ahead and let's just do number 1 together. All right, you'll have time to practice on your own with similar problems. But, you know, the book, the directions sometimes, they're asking us to do math, right? But there's so many different things and different ways of doing math, okay? So you should be looking at the textbook. I'm not gonna copy down the graph, okay? I will graph later and help you graph it, but we're looking at the graph, okay? In fact, you know what, for you, because we're new to each other, I'm gonna make a very, very bad drawing. Why is it bad? Because you know what? It doesn't need to be perfect, all right? And they give us an equation, and once I'm done talking and writing, I'm going to let you see what I'm writing, okay? So I'm gonna switch you over to my document cam, all right? Here's what we wrote in our notes. Notice I didn't copy down the core concept at the top of the page. I am not the student, you are, all right? Okay, like I said, a very bad drawing, right? Oops, and you know what? My pen, don't do math in pen, kids, but pencil doesn't really come out well on this. Anyway, now the directions say to identify the family. All right, so go take a look at this equation and take a look at your core concept. And what do you think it's called? I mean, what do you think the family? Do you think it's a constant? Does it look like a horizontal line? Do you think it's linear? Does it look like a slanted line? Does it look like a capital V? Do you think it's an absolute value function? Nope. I bet you think that the family is a quadratic because it is a parabola, right? It's kind of like a U, but it's not a U, the letter U. All right, and now we want to compare the graph of G. Okay, so they named it G. Remember, this is G of X. That's how we say it. And it just stands in for Y. Okay, it's the fancy way of writing Y. G of X, so this is G. Compare it to the parent function. All right, well, the parent function, according to, let's see if this red pen works, according to The book, if you look at the top, it starts at the origin, its vertex is at the origin, and it goes up, all right, and it's a little bit more narrow. So I noticed that G looks like it's been moved 3 units to the right. I apologize for pausing. I just want to make sure I use the right verbiage, as you will see in the textbook. It's important to be consistent. There's a lot of ways of saying this. So it looks like this parabola, G, in black here, if you can see the difference between my colors, moved 3 units right. Okay, do we all agree? All right, and if you look at the graph, you should see that the vertex moved 3 units to the right. And now here's the other weird thing, but it's actually, let's see, how can I do this correctly? This is actually wider than that. Now, none of these figures were drawn to scale, children, but we actually have a wider parabola. Okay, it was wider. We're going to get into looking in the equation and identifying which part of it tells us right or left, which part of it tells us wider or narrower. But for now, just looking at it with your eyeballs, all right, and it's a wider parabola. It's moved 3 units to the right. And so here, did we answer the whole thing? We should always go back, especially with this textbook. I've been using this textbook for a long time. It's always important to go back and read the directions again because they ask us for a lot. Identify the family function, boom, quadratic. Compare it to the graph of G, all right? It moved to the right and it looks like it's wider. All right, cool, we did it. At this point, you might be having questions. It's probably a good thing for you to pause, write down any questions you want clarified later. You're going to have a chance to ask me and to discuss with your classmates. So it might be a good idea now to write them down. Don't get too ahead of yourself, though. It's the first thing you've done in Algebra 2 besides sign the syllabus with your parents, okay? All right, let's do a couple different ones because I want us to get in the habit of graphing in an organized way, all right? Because we're all coming from different places. So there are great examples, ladies and gentlemen, students, there are great examples on page 5 on how to graph. You should read them. They might be better for you. I'm going to try to show you a different way to graph. Now I'm going to skip number 2. All right, I think we can graph a line. In fact, right now you should probably think, what's the y-intercept, what's the slope? But let's do something that you might not have done before. So let's do number 3 and let's do number 4, okay? So you can come back later and do number 2. All right, so the directions on page 5 for numbers 2 to 4, and I'm starting at 3, are to graph the function and its parent function, then describe the transformation. Okay, so you're in Mr. Mitchell's Algebra 2 class. I'm going to lay down some basic ground rules. If you need to graph, you, by default, unless I say otherwise, you should assume that I want 5 points, okay? And I always want you to stay organized. Now, I'll teach you, and you might already know some tricks on how to do it without a T-chart, but until then, we're going to use a T-chart, all right? And by the way, whenever you get to a math that you're just stuck on, and it's going to happen, it might not be this year, it might also be right now, but it could also be 5 years from now when you're in college, you can always go back to a T-chart to help you out. All right, so I don't really know anything about this function, so I always start with 0, 1, 2, 3, and 4 on my in my X column, okay? Make it simple for yourself, I don't know. I don't really know anything. All right, I'm getting to this just like you are. All right, so we're gonna go ahead and we're gonna plug in 0. Now you can do this in your head, or you can write it out to the side. So if you need to, you're gonna do 0 minus 2 in your head, which is -2, and then we're gonna square it. -2 squared is +4. You're gonna do 1 minus 2. Now again, you could do it in your head, as long as you're fairly confident you're gonna be right, or you can write it out. 1 minus 2 is -1, -1 squared is 1. 2 minus 2 is 0, 0 squared is 0. 3 minus 2 squared is 1, and 1 squared is 1. 4 minus 2 squared is, 4 minus 2 is 2. 2 squared is 4. Oh, and that's actually very pretty. Now we're going to, we don't need to draw the entire Cartesian coordinate system. Oh, I apologize that my pen is running out. Or the XY plane, as you might have called it before. We can always be smart about it. We're going to try to be neat, and you're going to find out that I'm not the neatest person in the world, okay? I'm not perfect. Shocking. right? And neither are you. But we are going to compensate for our lack of perfection with organization, all right? And it looks like what? I went 0, 1, 2, 3, 4 over here. And now I do need to have some of these for my parent function. So graph the function as parent. I didn't even know. Got to graph it. Okay. So we have 0, 4. We have 1, 1. We have 2, 0, 3, 1, and 4, 4. Now, let me say something right now. First of all, I've noticed some students in my past, they've actually not put the points where the points go. You need to do that. How do I know where the points are? Well, these are the coordinates that I got them from, okay? Now, let's say it's spring semester and you're graphing something and you didn't use a T-chart. Well, then you need to put the coordinates next to the point. Every point you write down for me. However, we wrote a T-chart, and if for my class, not every teacher does this, but for my class, if you have your T-chart, you don't need the parentheses over here, then you can have your graph next to it, and I don't need the points labeled. If you don't have a T-chart, you need to label your points because I am not really a mind reader, okay? All right, so we graph the function. Now we have to graph its parent function. So let's actually just play a game. Let's just square every number I say. So let's start with 0. What's 0 squared? It's 0. Let's go to 1. What's 1 squared? It's 1. Let's go to 2. 2 squared is 4. All right. You know what? And let's go. Okay. Let's connect the dots. Right. And now let's go backwards. What's negative 1 squared? It's 1. What's negative 2 squared? It's 4. So the parent function, you're just playing a game. The game is square the number. Pick an x, square it. You probably know why I started the origin. If you don't, think about it. All right, so graph the function and its parent function. Oh, now describe the transformation. Okay, so it actually looks like it's the same width, but we just moved right by 2. Oops, excuse you. I apologize. None of my pens are working on this paper. We moved right by 2. Okay, so go back to the directions. Graph the function and its parent function. By the way, the T-chart is part of the graph. Otherwise, you label the points neatly. And then describe the transformation, moved right by 2. All right, cool. Now, I'm going to move on to number 4. This is a little longer than most of our videos go. All right, so take a deep breath in and let it go. So most of our videos, we're not going to be sitting here this long, but this is your first video. And I also, prefaced it with best practices and good tips. Okay. This is how you say it, by the way. N of x is equal to the negative absolute value of x, or sorry, negative absolute value of x. The other way I did was in the, and then I apologize for no reason. All right, now, it's an absolute value function. Let's put 0 in the middle this time. Why did I do that? Well, maybe I am thinking ahead, or maybe you just think I'm a magician. All right, so what is the absolute value of negative 2? Okay, well, the absolute value of negative 2 is positive 2, but then there's a negative in front. What's the absolute value of negative 1? So do you see how maybe doing it in your head is going to confuse you? What's the absolute value of negative 1? It's 1. And there's a negative in front, so it's negative 1 again. What's the absolute value of 0? 0, put a negative in front of it. No, you're not going to put a negative in front of it, silly goose. What's the absolute value of 1? It's 1, but there's that negative in front of it. What's the absolute value of 2? It's 2, and there's a negative in front of it because you know what I'm about to say. Oh, look at our numbers. It looks like they don't go higher than 0. So if you can think ahead, wow, I am ink challenged today, and it's our first video. It's not actually the first video I've recorded. I'm going back and redoing some videos. But you would think my pens would be used to this. Now, I actually kind of did it wrong, but we'll get to that later. All right, negative 2, negative 2, put a dot. Negative 1, negative 1, put a dot. 0, 0, put a dot. 1, negative 1, and 2, negative 2. All right. There we go. It's an upside down V. Oh, but we have to graph the function, boom, T-chart, and this counts as your graph. We have to also graph the parent function. All right, kids, let's play a game. Let's start with 0. What's the absolute value of 0? It's 0. Put a negative in front of it. It's still 0. What's the, oh, sorry. I apologize. Delete, erase, rewind. What's the absolute value of 0? We're doing the parent function. The parent function is just the absolute value of x. What is the absolute value of 0? It's 0. What's the absolute value of 1? It's 1. What's the absolute value of 2? It's 2. What's the absolute value of negative 1? It's still positive 1. What's the absolute value of negative 2? It's still positive 2. Did you get that? I went nice and fast. So here's our parent function. Here is our, I call them a baby function a lot, but here is n of x. Here is our offspring function, also not actually a math term. So graph the function and its parent function, describe the transformation. It looks like, here's a vocab word, munchkins. It's reflected, oy vey, over the, my God, x axis. All right, I want you to think about it. Oh God, I'm sorry for my horrible handwriting. Dealing with a pen that doesn't want to work. What happened? It was facing up, flipped over, faced down. All right. Now, what you need to do, you need to go back and you need to do page 5, number 3, and there's going to be 1 or 2 more videos, I believe 2 more videos for chapter 1, section 1. All right. So, excuse me. Look at those technical difficulties. All right, so there you go. At this point, you should pause. You should rewind. You should copy down any notes that you might have missed. You might want to also copy down some English that goes along with that. Actually, that's something I didn't really talk about. It's really important. Children, math is just a language, all right? I know it can look really intimidating to some people, and that's unfortunate because it's really just like learning a new language. So if you take it from that mindset, if you just copy down these notes without writing like why, or at least some rationale. And maybe this is easy for you, maybe it is easy for you, and you don't need it, but chances are you do or you will sometime this year. So get used to writing words down, all right? I probably said something that's gonna help, pause, write it down, okay? You never know what's gonna come in handy later on, all right? Especially as the stuff gets more complex, okay? All right, anyway, you'll see me in the next video.